Hello students, we are back with the chapter aldehyde, ketones and carboxylic acid. Now student, in this module we are going to discuss again the method of preparation, and that is by aromatic hydrocarbons. Now student, here you can see one statement. Aldehydes are prepared from aromatic hydrocarbon by various methods. Let's see what those various methods are. So here the first method is by oxidation. The second method, if you see, it's nothing but a chlorination followed by hydrolysis. And the third method, the most important one, is a Geddemann-Koch formylation reaction. Now if you see in all these three reactions, you can only prepare aldehydes only, and especially you can prepare only aromatic aldehydes. Let's discuss the first one, that is by oxidation. Now student, when you go for this method, that is by oxidation, we'll take one example of hydrocarbon, that's a toluene. So here the first one is by oxidation of a toluene. Now I had got on screen a toluene molecule. Now this particular toluene molecule, suppose if I treat with some oxidizing agent such as potassium permanganate or a dichromate, what will happen? Your toluene group, that a methyl group, will get oxidized to an aldehyde. So the product what we'll get is nothing but benzaldehyde. But student, remember, the oxidizing agent what we are using, KMnO4 or potassium dichromate, they are strong oxidizing agent. So what will happen? Because of that, further oxidation will take place and you will get your answer as benzoic acid. Now, if you see student, what is happening in this is, a toluene is getting directly oxidized to an benzoic acid, where intermediate formed is nothing but an aldehyde. That means, in this reaction, it is difficult to stop the reaction at aldehyde stage. But student, remember, it is not impossible. So, we can stop this reaction at aldehyde stage by using suitable reagents, and those reagents you have got on the screen. The first one by using chromyl chloride, and second by using chromium trioxide in acetic anhydride. So let's student discuss one by one how we will prepare only an aromatic aldehyde by these suitable reagents. The first one I had got on the screen by using chromyl chloride. Student, on a screen I have got a toluene molecule. Can you see? Now when this toluene has been treated with chromyl chloride, what will happen? Okay, but in presence of some non-polar solvent, that's carbon disulfide, what I'll do is, I'll write that chromyl chloride in an expanded form little bit, and then what we can see, two molecules are used over here. So what will happen? From the toluene, I'll remove 2H, or I will show clearly 2H. What those H will do? H will get combined with this chromyl chloride part, and hence we will get some intermediate over here, and that intermediate, if you see, has got C. This is the remaining part. What will happen? The remaining part of the chromyl chloride will get added to this particular part, which will be O, Cr, OH and Cl2, and this is nothing but a chromium complex. Now student, this particular compound has to be hydrolyzed. Now when you hydrolyze this, what happens? Can you see that oxygen chromium bond? It will undergo a breaking, fission by a water molecule, so we call it as hydrolysis. Now what happens when you break it? So obviously breaking will take place at both the sides, and what will happen? You will get some byproduct, if you can see, and this is byproduct, you can see. But what is the remaining part? I have got an benzene ring. To that I have got CH, and you will have got two OH groups. Is it nothing but student, a gemeryl diols? And student, do you remember that gemeryl diols are, yes, unstable. So what will happen? From there on and on, it will be having a loss of water molecule, and can you see that water molecule loss? So what is left out now? A benzene ring with a CHO group. Is it nothing but student, a benzaldehyde molecule? Yes. So student, we have prepared from a toluene a benzaldehyde by using chromyl chloride. But student, remember, in boards when you write, you don't have to write each and every step. The thing which I am showing now on the screen, this is the part what is expected from you to write in a boards. Yes student, is it clear? Let's go to the second method student. So there is one more important note point. See, This reaction is known as etard oxidation, which is one of the very important entrance point. Let's go for the second one. So here, the second method, do you remember? Yes, it is from chromium trioxide in acetic anhydride. So here I have got a toluene molecule. Again, I'll take it an acetic anhydride in presence of chromium trioxide, student. Yes, what will happen? I'll write in the expanded form. Now what? We don't have the exact mechanism for it, but we can make it in a simplified form. So what I'll do is, I'll make those two H's available from the toluene. Those two H's and oxygen, suppose if they are removed, it will be lost as like a water molecule. And what do you get? You can see a same molecule I have written. Now the remaining part of that acetic anhydride, COCH3, can be attached. Yes. Now what is remaining? If you remember, there is one more important point. Is it nothing but chromium trioxide, an oxidizing agent? An oxidizing agent will provide us an oxygen. So here I have again got an intermediate compound. Again, what has to be done, student? Yes, it has to be hydrolyzed. And when you hydrolyze, what will happen? That oxygen and a carbonyl bond will undergo cleavage and a bond breaks. Now what? Can you see that byproduct what you have got over here? Yes, what is that byproduct? Can you locate? Yes, the byproduct is nothing but acetic acid. What will be the product form now? Yes, you have got a benzene with that CH having two hydroxy groups. Student, is it a geminal diol? Yes, student. What will happen? If they are unstable, yes, what will happen? They'll have a loss of water molecule and you will again get back your benzaldehyde molecule. Can you see, student, how you have got a benzaldehyde molecule? Now what? But again in the exam, while writing, you don't have to write all steps, please, student. The steps which are required for board exams are this. So yes, is it not easy? So student, we end this module over here. Thank you. Hello students, we are back with the chapter aldehyde, ketones and carboxylic acid. Now student, in the